Lesson 39, kinetic energy and potential energy. We'll split this up into two. It's quite a long lesson. The first part of this lesson talks about mechanical energy. And as you can see, the definition for mechanical energy is the total energy of an object. In this case, we're going to be talking mainly about potential and kinetic energy. So for example, a plane flying in the sky has kinetic energy because it's moving and has potential, gravitational potential energy because it is high above the ground. Whereas a car driving along the street really only has kinetic energy because it's on the ground, so it doesn't have any potential energy. Okay, then we go to kinetic energy. Now, you've done this in Science 10, so we won't spend too much time on it. Here's the formula for kinetic energy. Kinetic energy equals 1/2 times the mass of the object times the velocity squared. So any object that is moving has kinetic energy. And then there's this section here about relative to what? Because obviously if relative to this chair that I'm standing next to, I have no kinetic energy. However, if there's a person on the moon looking at me and the Earth is rotating, then I appear to be moving to that person on the moon. So that's where the question of relativity comes in. And then there's an example here. Example number 1 says a pop can with a mass of 312 grams is sitting in a cup holder of my car as I drive down the Yellowhead at 68 kilometers per hour. Determine how much kinetic energy it has relative to me in the car. Well, oops. The answer to that question is going to be 0, because relative to me in the car, the pop can is not moving relative to me. It's moving to relative to somebody standing on the side of the road. They would see the pop can moving, but to me in the car, it's stationary to me. So the answer to that is 0. And then for the B question, determine how much kinetic energy it has relative to someone standing on the side of the road. That's where we're going to go 1/2 times the mass times the velocity squared. And don't forget to change the mass into kilograms. Don't forget to change the velocity into meters per second. Don't forget to square the velocity. And once you do all that, you should end up with an answer of 56 joules. So there's a very basic standard kinetic energy question. More than likely, you're going to end up with a question such as this one, where you have to solve for the velocity. So we have, it just says, determine the velocity of a 150 kilogram cart if it has an energy of 3.6 times 10 to the 4th joules of kinetic energy. And this is such a common question in the physics curriculum that it's one of those formulas you may want to memorize the manipulation of it. So here is our base formula, and we're going to solve this one for V. What's the first thing we're going to do here? Well, the first thing you can do this in a number of ways, but let's multiply both sides by 2 to get rid of the half. Then let's move the m, get rid of the m by dividing both sides by m. Those will cancel out, and then we're left. I'm just going to reverse the order just so we're reading from left to right. V squared, therefore, equals 2 times the kinetic energy divided by the mass. And then the final step to this manipulation of formula is going to be we want to find V, not V squared, so we're going to square root both sides of the equation. The square root of V squared is simply V, and we end up with this. 2 EK over M. So the square root of 2 EK over M, and that is a formula you may want to memorize because it's quite common in the Physics 20 and 30 curriculum. And once we've got that formula, we just need to plug in the numbers. Okay, so take your kinetic energy, multiply it by 2, divide by 150, take the square root, and you end up getting 21.9 meters per second, which sounds like a pretty reasonable for the velocity of a cart. If you forgot to square root it, then you would get an answer of 440 something or more than that. You get a ridiculous answer. There aren't many carts going around that have a velocity of 440 meters per second. That's pretty darn fast. And example number 3. So this one's got a little couple of quirks to it. I'm driving my 2,500 kilogram Camaro down the street at 52 kilometers an hour. I noticed there is a school zone ahead, so I hit the brakes to slow down to 24 kilometers per hour. If I slow down over a distance of 145, determine the average force applied by the brakes. So what they're looking for is the average force in this question. Looking for force, let's write down what we have. We have the mass of the car. We have the initial velocity, 52 kilometers per hour, which if we convert it equals, I don't have my calculator here. Let me get it. $52 divided by 3, oops, 14.44 for repeating. And we have the final velocity, 24 kilometers per hour. 24 divided by 3.6 is 6.6 repeating. Okay, so what we're going to do for this question is we are going to use the work formula, but not work equals force times distance because we don't have the force, but we're going to use the work formula to calculate the change in energy. So step 1 in this question is going to be work equals the change in energy. And what happened in this question? I was driving at a certain speed. I slowed down, so I have less energy now. I have less kinetic energy because I slowed down. And the change in energy is simply going to be the final energy. Any change is always the final minus the initial. Oops. Final minus the initial, and again, we're talking about kinetic energy here, so that would be so you get your final energy, your final kinetic energy minus your initial kinetic energy. And if you want, you can factor out the 1/2 and the m, or you can just plug the numbers in, and what you end up getting, now of course you're going to get a negative number here because your final velocity is slower than your initial velocity. You end up getting negative 205,246 joules. All right, so that is the change in energy or the work. And now if I've got the work and I've got the, oh, sorry, I forgot to write down the displacement in the initial question. And now I also have the work. Right, and that's the work that my brakes did or the road did on my tires. Now I can use those values to figure out what the force is. So then just ends up just being the work divided by the displacement. Ends up giving you an answer of 1.4 times 10 to the 3 newtons. And you don't really need the negative again because work is a scalar quantity. So the negative is kind of irrelevant in this question. Okay, we'll stop there and then we will continue with this lesson. It will be lesson 39-2 coming right up.